Okay, so let's start today class. Today we are going to discuss about some problem based on the per unit system of single phase transformer. Okay, so just first of all share the screen and then we will continue our discussion. Okay, so let's share the screen and then we will continue our discussion. Okay, so here we consider some problem based on the single phase transformer in per unit system. Okay. So in the single phase transformer of voltage rating given to you 2300 volt divided by 230 volt having a JEH in per unit equal to 0.03 per unit. Find the voltage drop across the HV winding. Okay. So find the voltage drop across the HV winding. Okay. So this equivalent impedance on the high voltage side is given as the 0.03. Okay, so this one you can be just give the value of voltage drop on the high voltage side. This one impedance drop. Okay, so high voltage side your voltage rating is 2300 volt, and just you convert that means this one. So 3 by 100, then you will equal to 69. Okay. So voltage drop is given by the impedance, whatever the in percentage of the impedance that you require to find the value of high voltage side. Okay, so high voltage side is 2300 volt. So just if you convert this one, that means 3%. This per unit value is converted, then you just multiply by 3 into 3 by 100. Okay. With the high voltage side voltage rating, that is 2300 volt, that is nothing but 69 volt. Okay. Similarly, the second problem, we just find out the ohmic loss at the rated voltage. So ohmic loss at the rated voltage is given as the single phase transformer of 10 kVA, the voltage rating given to you 2300 volt, 230 volt equivalent resistance of the high voltage side is equal to 0.018 per unit. So find the ohmic loss at the rated current. Okay, so ohmic loss at the rated current is given by the per unit value of the equivalent resistance that will be directly multiplied with the power rating of the transformer. Okay, so the power rating of the transformer is given to you 10 kVA. So that 10 kVA you may be converted into volt ampere. Okay, by multiplying the 1000. So this one 10 into 1000 it becomes 10,000, and just directly equivalent resistance drop on the high voltage side given as the 0.018 per unit. So this one is directly multiplied by the power rating of the transformer that will provide you resistance on the high voltage side on loss value. Okay, so if you multiply this equivalent resistance of high voltage side, that is equal to 0.18 per unit, and that will provide us the ohmic loss at the rated current, and impedance drop is given to you voltage drop across that winding, either high voltage winding or low voltage winding. Okay, so these 2 points you always kept in your mind when you are going to solve some problem related to per unit of the transformer. then per unit impedance value is given to you, voltage drop of that side, and resistance provided in per unit, that resistance multiply with the power rating of the transformer, that will be provide you ohmic loss at the rated current. Okay, so these 2 points is very important. You may find out some direct objective problem based on these two concepts. Okay, so you just the data given in any problem and just simply find out the voltage drop, either the high voltage side or low voltage side. If impedance given in per unit, then you just simply multiply with the per unit value of that side impedance, that means high voltage side and low voltage side, with that voltage. Okay, suppose that here in this problem we given in the problem, that means equivalent impedance on the per unit side, that is 0.03 per unit. Okay, 0.03 per unit. So if you impedance drop, that means provided you in equivalent impedance of the low voltage side in per unit, that means ZEL in per unit. Okay, so you can directly obtain the voltage drop across the LV winding with the multiplication of per unit value of impedance with the voltage of the low voltage side. That means 230 is multiplied with the ZEL in per unit, whatever is given to you in problem. Okay, so this concept is very uh, much requirement whenever you are going to solve some problem based on the per unit value. Okay, so either may be given in high voltage side or given in low voltage side. Okay, so just to per unit value multiply or from that side of voltage. Okay, from that side of voltage, just provide from that side of voltage and per unit value. Okay, so 2300 into, if you represent this one in percentage, that means 3%. So 3 divided by 100, that will give in per unit. So this one will becomes 69. And when the equivalent resistance given in per unit, that will provide you ohmic loss at rated current, when you provide multiply the equivalent resistance of high voltage side or low voltage side with the power rating of the transformer. Okay, so in this problem given to the high voltage side equivalent resistance in per unit. Okay, we maybe obtain that the uh, equivalent resistance on the high voltage side and low voltage side as similar. These things we may be seen in the next class. Okay, so here in the third problem, this one. Okay, so ohmic losses at the rated current equal to 0.018 into 10,000 equal to 180 watt, directly given to you. Next problem, we just consider that third one. Okay, we just consider third one, that means so the per unit value of REL, JDL, and so the per unit value of REL, XEL, JDL are equal to the per unit value of REH, XEH, and JDH. What is represent here? REL, that means in suffix of EL and in suffix of EH. That means we want to prove here that equivalent resistance of the low voltage side, equivalent resistance of the equivalent leakage reactance of the low voltage side, and equivalent leakage impedance on the low voltage side is equal to the equivalent leakage impedance on the high voltage side, equivalent resistance on the high voltage side, and equivalent impedance on the high voltage side are equal. Okay. Hello. 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 थोड़ी देर बाद कोई है ना क्लास लगी। So we want to prove here that the current resistance on the low voltage side, equivalent resistance of the low voltage side, and the impedance on the equivalent impedance on the low voltage side and high voltage side are equal. So just we try to prove this one. Okay. So as we know that REL in per unit is equal to nothing but REL, that means in ohm, divided by base value on the low voltage side. Okay, so this ZBL represent here the base impedance on the low voltage side. Okay, as we know that any quantity can be converted into per unit quantity by actual quantity divided by the base quantity. Okay, so it is nothing but the ratio of the actual quantity to the ratio of the base quantity. Okay, so REL in per unit equal to REL in ohm divided by base impedance in ohm of low voltage side, that is represented by ZBL here. Okay, so ZBL is nothing but low base impedance on the low voltage side. Okay, so REL in per unit can be written in terms of REH, means equivalent resistance in high voltage side. So if you want to convert this one, then we can write here REL equal to REH into NL by NH. That means low voltage side turns divided by high voltage side turns ratio square. As we know that how we can transfer from one side to another side, that means low voltage side to high voltage side for resistance, leakage reactance or impedance. Okay, so just use that formula and this can be converted REL equal to REH NL by NH whole square. So just you put here the value of REL in terms of REH. Okay, so just put here, that means in terms of REL. So REL equal to nothing but we can put this value in place of REL divided by base value. Okay, so REL in per unit okay. So REL in per unit suffix EL represent the equivalent resistance on the low voltage side. Okay, that equivalent resistance on the low voltage side can be represented in the terms of high voltage side resistance equivalent. Okay, that is represented by REH. So REH into NL by NH whole square divided by Z base impedance of the low voltage side. Okay, so just this one try to change. So REH the same as the previous one. So ZBL into this NL if you want to write here. Okay. So so this REH just try to write here same as the REH divided by Z base BL into this NL if you take as the denominator of this part, so we can write here NH by NL whole square. Okay, so this value can be replaced by the ZBH, that means base impedance on the high voltage side. Okay, if you remember how we can transfer the resistance, reactance, and impedance from one side to another side in transformer, so we can just represent this value by the impedance of the high voltage side. Okay, so this one becomes nothing but REH divided by ZBH. This is nothing but REH in per unit. That means equivalent resistance in per unit. Is it not? Equivalent resistance in per unit. Because this one is the ratio of equivalent resistance on the high voltage side divided by to the base impedance of the high voltage side. That means REH by ZBH equal to REH in per unit. Okay. So REH in ohm divided by ZBH in ohm. That means actual value in any unit divided by the base value in the same unit. So you may be observed here that resistance actual unit in ohm that can be represented in ohm, so that the base impedance value is also in the same unit, that means in ohm. Okay, so REH by ZPH is nothing but REH in per unit. Similarly, this one is for the resistance. R represent here for resistance. Similarly, if you want to represent the per unit leakage reactance of the low voltage side, that is also becomes as the equivalent leakage reactance on the high voltage side. Okay, so XCL in per unit equal to XCH in per unit. Just the same formula you have to use. Instead of R, you just replace this value by X for the reactance. It not. Suppose that if you write here XCL in per unit, that means if we want to write here, so just write here. That means XEL in per unit X, that means leakage reactance equivalent leakage reactance on the low voltage side is XEL in per unit equal to XEL in ohm divided by ZBL in ohm. Is not. So XEL in ohm, XEL in ohm divided by ZBL in ohm. ZBL in ohm. Okay. So similarly, we can replace this value XCL equal to in terms of RE XEH. So just write here XEL in terms of XEH. So XEH XEH divided by ZBL into NL by NH whole square into NL, that means low voltage side number of turns, that is represented by N suffix L, NL divided by number of turns on the high voltage side, that is represented by this one, NH whole square. So just this one, we can simplify. That means XEH X H divided by ZBL ZBL into NH by NL whole square, NH by NL whole square So this one can be represented as ZBH. Okay. So this one equal to XEH divided by ZBH. XEH X H divided by ZBH. ZBH. So this is nothing but XEH in per unit. So this is nothing but X EH in per unit. This is nothing but in per unit value. Okay. Similarly, you can convert the JDL in per unit equal to JDH in per unit. Both are equal. Okay. So this one JDL in per unit, it is written here. ZEL in per unit equal to JDL in ohm divided by ZBL in ohm. So this one is nothing but ZEL in ohm, ZEL ZEL much, but ZEL in ohm per unit ZEL in per unit equal to ZDL in ohm divided by ZDL in ZBL in base value of ZBL, that means low voltage side. So this is nothing but ZEL in ohm, ZEL in ohm divided by ZBL in ohm, ZBL in ohm. So this JDL, if you again convert in the JDS, that means equivalent impedance on the high voltage side. Okay. So can be NL by NH whole square. So just to write here ZEL in ohm, ZEL LEH into NL by NH whole square. This one is your ZBL. So ZBL NL by NH whole square. And number of turns on the low voltage side to the number of turns of the high voltage side. Okay. So just to the whole square. Number of turns on the low voltage side divided by number of turns on the high voltage side. Number of turns on the high voltage side. So whole square. Whole square. So this can be written as JDH EH H divided by ZBL GL into NH by NL whole square. NH by NL whole square. uh, NH by NL whole square. So this one simply we can write here NBH. That means base impedance on the high voltage side. Okay. This one is becomes ZEH divided by ZBH. That is base impedance on the high voltage side. High voltage side. Okay. So this one again the ratio of the any quantity in actual value divided by the base value in the same unit. So that means we can represent this value as ZEH in per unit. You know. So ZEH H per unit per unit. That means all the parameters of the transformer in two winding transformer. That means either primary side, you maybe say that in primary in terms of primary or secondary, or you maybe say that in terms of low voltage winding and high voltage winding parameters are equal in the per unit. Okay, not in the actual unit. That means both side parameters are not equal, but anywhere you convert the parameters in per unit. Okay, so that per unit value is equal either in low voltage side or maybe find in terms of high voltage side. Okay, so either in the resistance, if you convert it in low voltage side equivalent resistance in per unit, so that is same as or maybe equal to the equivalent resistance of the low voltage side. Okay, but not exactly the same things happens in the actual quantity. That means resistance are in ohm. That means that parameters may be a different value. But whenever you convert resistance or the resistance, reactance, or impedance in per unit, okay, in per unit, that means either low voltage side or high voltage side, that will be equal. Okay, so maybe directly use this formula where you solve an numerical problem related to this type. Okay, that means in per unit. So you may be specify in particular type of problem, that means per unit resistance of every side given to you, and just ask the what is the per unit value on the low voltage side. Okay, that means simply you have to take same value in per unit value. Okay, that means same value either low voltage side or high voltage side, all are equal. So these things, this is very basic things of the quantity converted in per unit. Okay, either maybe resistance, reactance, or impedance. 3.8. Either you maybe simply maybe convert the uh, voltage current also in per unit. That means high voltage side, low voltage side, voltage and current also can be represented per unit, single phase. Okay, so just keep all these points in your mind, and whenever you solve and if you require, directly use this property of the per unit. That means any quantity of low voltage winding side or high voltage side winding side are equal. Okay. So you may be careful about these things and see, very simple. What we consider here that we really just consider the transformer part. Okay. In actual power system, we maybe find out other components of the electrical equipment. That means maybe transformer, generating power alternator. That means alternator. So we can say that alternator, transmission line. Here you have to careful about the base voltage and base impedance. Okay, base voltage and base impedance you just take as the highest value of any component in your system as the base value or base MVA. Whatever the highest value of any particular component in your power system, where either maybe transmission line or maybe transformer or maybe uh, alternator. Okay. All are specified their power rating and voltage rating. Okay. And their data, that means parameters, reactance value may be given in per unit, but on their based on voltage and base MVA rating. Okay. So that per unit value may be convert on another base voltage and base MVA rating. Okay, so we already know how we can transfer any particular per unit quantity if given on any specified base value and base voltage. So we can convert that per unit value on the another base voltage and another MVA rating. Okay, so that formula we already know that if you require to convert this type of quantity in your actual power system, then you just use that means Z per unit new, Z per unit new. That means on the another base value and MVA rating, then simply just to write here J per unit of old value, that means given in your problem on some base voltage and base MVA. So that is represented by old value Z in per unit or resistance in per unit or reactance in per unit into MVA new by MVA old. Okay, that means whatever you choose the new MVA and divide by the MVA old into kilovolt base old by kilovolt base new whole square. Okay, so you maybe use this formula or convert the per unit quantity on a specified base voltage and base MVA on another base value and base value of voltage and base MV. So you maybe directly use this type of formula here. Okay. Okay, fine. You may find some more problem based on this formula and you just solve and practice all these things. Okay. So just we stop here and in the next class we will discuss another things. Okay. So we will practice some problem based on this. Okay, fine. Just